Hi, everyone. My name is Danielle Fradet. Like Ann said, I am a junior specialist at the UC Davis Museum of Wildlife and Fish Biology and the first recipient of the Yolo Audubon Small Grant. So today I'm going to talk to you guys about automated recorders, how they can further ornithological research. So a little bit about who am I? I am currently a junior specialist, but when I received this grant, I was a senior at UC Davis studying wildlife, fish, and conservation biology. And I was an undergraduate intern at the museum. So I started working there when I was a freshman, and I worked there all the way through my senior year. And I was also in the honors program. So one of the requirements of being in the honors program is that you are to complete a capstone project in your senior year. So with the museum's help, we came up with conducting an automated recorder unit study to survey breeding birds at a private property in the Sacramento Valley called Birdhaven Ranch. I then applied for the Yolo Audubon grant and was lucky enough to receive it, which gave me the funds to buy equipment and enlist help with data analysis, and also sponsored my time working on the project. But before I get into the methodology of the automated recorder units, I wanted to give some context on the project and the museum and how we kind of came up with it. Um, but first of all, I wanted to just do a quick thank you to everyone who was able to support the project. So first, I want to thank the museum. So right here is Andrew Inglis, who's the curator of the museum, and with its research projects in national and international scope, um, this museum has obviously a lot of experience in research and has focused recently on the Central Valley. And my project has been thoroughly tied to those efforts. So I want to thank them. The man next to Andy in the plain photo is Paul Bonderson. He is the owner, him and his wife, Sandy Bonderson, are the owner of Birdhaven Ranch, where my study takes place. And they also provided financial support for the project. So I want to thank them. Any of the volunteers who helped with my project, I also wanted to thank, as well as Brett Furness. He was an ecologist from CDFW who helped with data analysis. And then also finally wanted to acknowledge Yolo Audubon Society again for providing their support. I'm really happy to be here to talk to you today. So just to give some context, the mission statement for the museum is to support teaching, research, and outreach through the maintenance of a vertebrate collection dedicated to documenting and understanding taxonomy, biogeography, and life history of vertebrates. So the museum has done much research in the Central Valley where it's based. So these are lists of some of the projects we've done. Currently ongoing, there's the Poudre Creek Terrestrial Wildlife Inventory Project, which I've worked on, and it's been monitoring wildlife, especially birds, along the Poudre Creek for nearly 20 years. And that project relies a lot on private properties. There's also the Poudre Creek Nest Box Highway, which has been going on for 20 years, and it monitors and bans cavity nesting songbirds along the creek, such as tree swallows, house wrens, western bluebirds, ash throateds. If you've done any, birding or hiking along there, I'm sure you've seen the nest boxes hanging around. And then there's the Sacramento Valley Avian Inventory Project, which is a specimen-based survey of the birds in the Sacramento Valley, and I'll touch on that shortly. And then there's the Delta Project, which is a contract from DWR, where we're monitoring biodiversity in areas where they're doing subsidence restoration. So when we were looking at projects to do, Andrew Inglis was thinking about focusing specifically on a specimen-based survey of avian diversity in the Sacramento Valley. So the museum started this project, and it establishes some of the goals of this avian inventory of the Sacramento Valley were to establish a 21st century benchmark of avian diversity with voucher specimens. They wanted to look for migratory connections. We also wanted to establish a comprehensive tissue collection for the Sacramento Valley birds. So anytime we prepare a bird from this area, we would take a tissue sample from it and save it in our cryofreezer. And then we also wanted to build relations with the private sector. So these stars on the map are locations from where this project has collected specimens or done any form of research. So the top upmost star is Rancho Escuan, which is a duck hunting club. Then there's Birdhaven Ranch, which is where my study took place. It's also a duck hunting club. Then you have various private properties in Colusa County, various properties in Sacramento and Yolo County, and then the lowest one is Consumnes Preserve. And then Birdhaven Ranch is where all of this started. So why the Sacramento Valley? Why do we want to do this specimen-based research here? So in the late 1920s, or in the 1920s, Joseph Grinnell went through California and surveyed and collected birds from their associated habitats all throughout the state. So often this was the first time such data had been collected. However, when he got to the Sacramento Valley, he believed that it had already been too much altered by humans. And also it was incredibly difficult to get around in the valley at the time. There's lots of marsh, there's extensive flooding. So he just decided it wasn't worth the effort. And so no initial benchmark of biodiversity was made in the Sacramento Valley, which is a problem because we don't have specimens to compare to the past to see whether we've gained or lost biodiversity or how species have changed in the valley over time. And then John Emlyn, he was a zoologist at UC Davis, and he recognized that there was this big kind of blank area. And so he started doing migratory bird surveys in the 1930s on campus in the surrounding area, but his work was never completed. So also the Sacramento Valley has been a target of much habitat restoration since the 1960s and has been expanding refuge systems, and also there's been restoration on private lands. So helping to reclaim, and the development on the private lands has helped reclaim some of this developed area and provided more of a reason to understand the baseline biodiversity of avifauna in the Sacramento Valley. So another one of the goals of the project was to understand or to inform the private landowners of how their efforts have affected diversity. So this project is fully funded by private lands, and so it is important to recognize how private landowners have provided a lot of habitat for wildlife in the Sac Valley. And by doing so, it helps get their incentive for private landowners to restore maybe more area on their property, or to maintain the restoration that they've already done and let them know that what they're doing is actually making a difference. So for example, these photos are all taken from Birdhaven Ranch. So they're just beautiful photos of the property there. And then kind of a fun side effect of doing a project like this is that it gets undergrads involved in training for field studies so they can be better wildlife biologists. So this is, again, all photos from Birdhaven Ranch. And all of my field training has come from Birdhaven in my work up there. So I've done, on the next slide, this is some of the work we've done at Birdhaven, and I've done all of this work up there. So I've gotten to learn how to collect specimens in the field. I've gotten to learn how to do mist netting, transect surveys, small mammal surveys. Then I've learned how to band birds and lead field teams up there. So all of this work has come from just working at Birdhaven. It's been really awesome to get to do that. And it's allowed me to be a wildlife biologist, which I really appreciate. Birdhaven is also a great example of how a private property that's been partially restored and managed for wildlife in the Sacramento Valley can have these far-reaching effects. And it's also the home of my project. So I'll explain a little bit more in detail about this site. But the cumulative results of the Sac Valley project inventory project so far is that we've had 215 species of birds documented, and 155 species have been documented by specimens, and 73 species have been confirmed or probable breeding, and there's also been some biogeographic connections that have been developing. So the photo that you see here is specimens that were collected at Birdhaven Ranch, and then they were prepared by undergraduates like me at the time or by people that work at the museum. So while we were all working on this project, another research effort was being conducted in the Sacramento Valley that Andy assisted in, and that was the Great Valley Avian Occupancy and Habitat Use. So this project was spearheaded by California Fish and Wildlife with UC Berkeley and UC Davis, and it was a landscape use of audio recording units. So it looked at audio recording units in relation to overall habitat. So this project used audio recording units to find habitat associations with bird species and to also understand how understand bird patterns of distribution like hotspots, for example. And this study was important because it looked at avian response to the novel habitat that humans have created in the Sacramento Valley through their various forms of development, such as housing, agriculture, etc. So it shed some light on how birds are adapting to these changes that we've made on the landscape. So why audio recording units? Why would this project choose to use audio recording units over your standard point count, for example? So this method has some unique benefits compared to those examples. For example, you could have multiple reviewers review an audio recording, and this allows less bias in the data because you can have multiple people look at it. You can also get simultaneous collection of data. So on an audio recording unit, you can have presets for recording times. So it allows for simultaneous and synchronous collection of data, which increases standardization of your data. And additionally, it's a non-invasive method. So you can get data collection without the presence of a person. And I know, if you're birding, you step on as you're moving, you may flush a bird out, or you may move a flock, or you may scare it away. And so by just having these there, you are removing that presence of a person. And also, researchers have found that audio recording methods yield similar results to point counts truncated at 50 meters in diameter in single species, single season occupancy estimates when conducted in a side-by-side field test. So this Great Valley project had many locations where they used audio recorders all across the valley. So this was a big project. It was about 500 sites. So you can imagine that in order to collect enough data in one breeding season at all these sites, you would need to have a massive amount of manpower and skilled biologists in order to visit all the sites, and it would be incredibly difficult. So with the audio recording units, they were able to free up some of that manpower and just stick them out of sight, leave them for a couple days, and if you had enough, you could do that at multiple sites in a day, and you're able to collect huge amounts of data necessary to feed the occupancy model. So this is some of the results from this project. So this is the mean occupancy probability for songbird species across the Great Valley. So basically this graph is saying that anytime you're in the valley, this is the probability that you'll find a bird occupying that site. So it's important to note that this study was only looking at breeding passerines, so that's what's shown on this graph. But as you can see, habitat generalists are more likely, on the left, they're more widespread, like your black-headed or your brown-headed cowbird, house finch, northern mockingbird, while the more habitat-specific species, like the western wood pewee, white-breasted nuthatch, they're less likely to be found commonly throughout all parts of the valley, so their occupancy probabilities are a little lower. And then this next graph is showing occupancy based on distance to forest habitat. So as you start on the left, these birds are more likely to be associated with forests. And then as you go to the center line and you hit the 0, those are birds that are more your edge or ecotone species. And then as you go to the right, you get birds that are more, that are habitat associated species that aren't related to the forest. So grassland, scrub, marsh associated species. And this project was really cool because it's showing you that with audio recording units, you can begin to understand how birds are being distributed across the landscape and how they're using the habitat. And it allows you to gather lots and lots of data. So this is the final graph from the study that I'm going to show you. And it's a thunderstorm map that is showing you essentially richness hotspots across the Great Valley. So the smaller red is showing higher spots of species richness of birds and green is lower. The red linear patches are pieces of riparian habitat, and then there's two kind of major big red splotches. And the upper one is grassland regions in the San Joaquin Valley, and the lower one is it's diverse, mostly agricultural sites. So you've got orchards, vineyards, fields, pastures, and some riparian areas in Fresno County. And this is showing you basically that heterogeneous habitat is what is going to boost species richness, which is cool. It indicates that the birds in the novel landscape that we've created are able to sustain species richness. So then now specifically onto my project. So I wanted to test if audio recording unit method is viable on a smaller scale. So if ornithologists could measure and advance our understanding of habitat use and factors influencing occupancy with this method, that would be really great because this is necessary information for conservation. And then the second goal would be to measure diversity and habitat use of individual species, many of which remain poorly understood in the Sacramento Valley. So for example, like if this method works, you could look at targeting species of special status to see how they use habitat specifically on a local scale, which would be really important to decide how to best manage their populations. Um, and then another side point would that be developing this method would serve as the baseline to allow proper training and engagement of future students to conduct similar studies. So I could train undergrads on this project if it worked and help them become more viable when looking for jobs and give them understanding in this new like cutting edge technique. So now going from like the large scale, that Great Valley Avian project to the small scale of Birdhaven. So this map is sort of showing that you've got the state of California, obviously, and the gray outline is the Sacramento Valley, and then you've got Glenn County, which is zoomed in, and you've got I-5, the Sacramento River, and then in that southeast corner, you've got Birdhaven Ranch, which is that little black dot. So this is Birdhaven Ranch. It's one of my favorite places in the world. I really like going there. Birdhaven Ranch is a 1,020 hectare private duck club in Glenn County, which since the 1960s was managed for rice farming. However, since like 2000, approximately half of the existing hectares have been restored to seasonal marsh with extensive water delivery and control systems. In addition to the managed wetlands, Birdhaven protects a valuable oak riparian corridor, which runs the length of Howard Slough. And there are three basic habitat types at Birdhaven. You've got rice, managed marsh, and riparian. And so from this aerial photo of Birdhaven Ranch, you can sort of see that you've got the various managed marsh systems. You've got the riparian corridors coming up through the center of the property, and then you've got some ag fields over here. So you can see it's a very heterogeneous landscape and just a beautiful property that's got lots of habitat for various wildlife. So this is some photos that was taken on these are all photos from Birdhaven of the rice habitat. So in the top left corner is rice that was planted in late April or early May when the crops are reaching, when they had just shortly planted them. And then on the top right, you've got the rice at maturity in July. And then the bottom left, you've got right after in the fall when it's been harvested. And then you've got sandhill cranes that come out and hang out on the harvested rice and a bunch of other fun birds. And then in the bottom left, or the bottom right, is the rice in the winter when they flood it to become habitat for the waterfowl. And then these are some of the birds that you'll find on, these were all birds at Birdhaven that we saw. And these are all birds that you'll see in the rice. So you've got snowy egrets and American bittern, the killdeer, and the white-faced ibis. And you'll see the snowy egrets and the ibis hanging out in the ponds during the wintertime or in the spring as they're being drawn down. And then the bittern, I just love them. They have this coolest call. And then the killdeer, they like to nest they're there all year, but they like to nest in the gravel roads along the property. And when I was doing work up there, I found a nest that with 3 little eggs, and there was a female doing her broken wing display, which is really cool to see. And then you've got the marsh habitat. So this property, much like any of your other refuge systems or other private duck hunting clubs, is managed carefully each year to ensure that the habitat can support breeding in large numbers of wintering waterfowl. And the restored wetlands on this property consist primarily of managed seasonal marshes, which are divided into pond units, like you saw in that aerial photo. They're all kind of in rectangular units with independent levee and water control structures to regulate water depth and maintain independent water control. And the management at Birdhaven includes 3 hydrological systems. You've got summer dry, moist soil, and permanent water. So in the top left, you've got what it looks like in the spring, where they draw down the water. In the summer, you get summer flooding that they do to sort of increase seeds. And then in the fall, that water, they'll pull down the water again. And then all those seeds will come to bear. And they'll have a bunch of food available for all of the birds that are coming through. And then in the winter, you get, they flood them up again to become habitat for hunting. And also, these ponds create home for tens of thousands of ducks. It's really amazing how much that this property is able to support. And then you've got the marsh birds. So you've got your mallard mom and your marsh wren, which you'll hear later, and you've got common yellowthroat and also the song sparrow. So very stereotypical marsh birds. And then we've got the riparian habitat. This is my favorite habitat at Birdhaven. It's really unique and beautiful. It's a significant natural and native riparian corridor that's composed primarily of valley oak and Oregon ash as the canopy species, and they run the full length of the property. And then in addition, there's managed willow, cottonwood, riparian habitats that exist around most of the managed marshes. So you can see on the top left, it's me and one of my coworkers setting up an audio recording unit in a thicket. And then in the top right, there's a big meadow on Birdhaven's property. And that's photo standing in the meadow looking at the valley oak riparian habitat. And then in the bottom right, you've got Howard Slough, which is the water that runs through. And then in the bottom left, you have the willow cottonwoods that are around the marsh. So in the oak riparian habitat, these are the birds you'll find there. You've got your Nettles woodpecker, oak titmouse, ash-throated flycatcher, which is one of the birds we get in the nest boxes up at Birdhaven. Then they're more of the later breeders. So usually the house wrens will come in first and kind of take over, and then the ash-throateds will come in after. And then we've got the black-headed grosbeak, and I made that picture really big because they're my favorite bird. I think they're really beautiful, and they're all over Birdhaven in the spring making their noises and songs. And then you've got the willow riparian. So you've got your belted kingfisher along Howard Slough. You've got the house wren. Again, they're one of the main breeders up there in the Nest Box project. Last year, I banded over 175 house wren babies, which was really fun. And then we've got the Lasley bunting, which we, one time at Birdhaven, we set a mist net up in a cornfield, and the Lasley buntings were feeding on the corn. And so we were able to catch a lot of them in the mist net through that, which was fun. And then we've got the western wood pewee. So now going on to methods. So this is an aerial map of Birdhaven Ranch, and this map was created by Jason Riggio. He's a postdoc at UC Davis for the museum. And the white outline is the property boundaries of Birdhaven. And we gridded it out into 300 meter square plots. And that was important because it is the amount needed to maintain sampling independence and prevent overlapping surveys of the audio recording units. And then these black dots represent the center of each point, and you want to put your audio recording unit there so you have max distance between the plots, while also making sure that you're in the deepest part of the habitat, so you're actually sampling the suite of birds that you want to be sampling. And then the plots were then categorized into the type of habitat that they were. So there's the rice is the purple, the marsh is the blue, and the riparian is the green. Oftentimes the riparian habitat didn't actually take up a whole 300 meter square plot, but if the corridor was running through it, we marked it as riparian. So then to actually choose our microsites for the study, what we did is we assigned each of the boxes a number, and then we used a random number generator to get 10 plots from each habitat type, so totaling 30 study sites total. So for the actual audio recording unit settings, so we use 10 Olympus DM720 recordings for a study, and they're just your little held recordings. I actually see people using these in my lectures when recording my professors, so it was kind of funny that I was using these for my study. So in order to compare data with the Great Valley Survey project that I was talking about earlier, the recording settings were set in accordance with that project's methodology. And we actually had people who had worked on that project in the Modoc Plateau come out and train us in that method. So what we did is we set the recording levels to high, and that was so we could get hear the most birds that we could. And then the recording mode was set to 320 kilobytes per second, so to get the clearest sounding recording. And the zoom mic was set to -3 to get the widest circular range of sound. And then we set the central mic on. And then all of the unnecessary features, such as the low cut filter, VCVA, VSync, and the rec scenes, were turned off. And then for the actual recording times, for each recorder, we made 3 presets so that they could automatically record 5 minutes of audio at 30 minutes before sunrise, at sunrise, and then 30 minutes after sunrise. And then these presets were recorded daily once they were turned on. And the recorder needed to be left out for a minimum of 3 days for a total of at least 9 viable recordings per site, following the Great Valley protocols. And then we left them out for longer just in case we would get rain or wind that would make some of the recordings not able to be interpreted. And you want 9 recordings because you want to give 9 chances to detect the presence of a species at a specific site. So hopefully by having 9 chances, you're increasing the chance of hearing all of the birds there. And in addition, each recording, so each of the 9 recordings you get, could be treated as an independent sampling event. So since we had 10 sites, you would get a total of 10 sites per habitat, you get a total of 90 recordings per habitat type, which would be the minimum amount needed to feed to the occupancy model to get any results. So these were the recording dates that we did. Since we only had 10 audio recording units available, we couldn't deploy all of them all at once. So we had a team of volunteers who would go out to cover all 30 sites. So the first round we collected in mid-May, the second round was late May, and then the third round was in mid-July. And the first 2 rounds were in the riparian and the marsh sites. And then the third round we delayed for so long to give the rice the time to grow and reach maturity so it could have had enough reasonable habitat for the birds. And then all the rice recordings were done in July. So actually deploying the audio recording units. So what we would do is we would go out to the designated location on the property and then take the supplies as deep into that plot as we could. And then once we were at the desired location, we would use our extremely, as you can see, our very high-tech setup that we had going on. Basically what we do is we take a gardening pole and we shove it into the ground. And then we would get a little Ziploc container that I had poked holes into the bottom of all 4 corners. And that would be zip tied to the gardening pole. And then we would take a styrofoam block and a hair tie, and then we would take the audio recording unit that had been turned on and all the presets were turned on, and that would be held onto the styrofoam block with the hair tie, and that would be elevated off with the styrofoam block off the bottom of the unit, and then the top would be put on, and that would protect the audio recording unit from anything landing on it, or if rain would come through, then the holes would let the water drain through and it would be elevated off of the bottom of the box so that it wouldn't get destroyed. And then also having it attached to the top of the gardening pole would prevent it from being destroyed by flooding, which actually happened at one of our sites, so I'm glad we did that, and just prevent any animals from fidgeting with it. So in this photo, I'm collecting the data, and then Jake on the left is setting the presets and making sure everything looks good. And then Lynette Williams is setting up the audio detector setup. So then for the actual data collection, for each of the audio recording units, I would record down the audio recording unit number, the plot name of where we were deploying the audio recorder, and then I would get the lat and long of that exact spot where we were putting it. And then I would also write down the habitat type in order to make sure that we didn't get anything confused when we were going through the audio files later. And then we also would leave them out for at least 3 days, and then we would take cardinal photos. So these cardinal direction photos were really important. They would give a sort of picture of what the habitat looked like, because I know all of you guys are really big birders. You definitely know that when you're out birding, habitat is really important to identify. So to give you an idea of what birds may be there. So when you're getting an audio recording file and you're just listening, you're kind of in no man's land if you don't really know where you are. So these photos you would look at before you would do the interpretation of the audio recording to make sure you kind of know where you are. And this is an example of one of our riparian sites. So then we would go and we would collect the audio recording units. So to collect them, we would relocate them using the GPS units. And then we would mark down if there are any audio recording failures. So I'd make sure that we had at least, if we left them out for 4 days, I would have 12 recordings, or for 5 days, I'd have 15 recordings, etc. And then I would note if there looked like there was any rain that had occurred, or if there was any disturbance, like if an animal had, tried to get in or something like that. And then we removed all of the equipment, and we separated the audio recording units into individual folders to make sure that they were kept separated. And then doing the actual data interpretation. So we had 3 days of MP3 recordings, or 9 sessions were analyzed for each of the sites that we used using the Raven Pro 6.0 software from Cornell Lab of Ornithology. And this software allows the listener to have a visual sonogram of the sounds that you hear in the audio recording. So while you're listening, it plays and you can see as you're going along as you're listening. And I used Bose Quiet Comfort 2 headphones with the noise cancellation on high to listen to each 5-minute recording, and also the volume all the way up, so I could hear as much as I could. And then what you would do is you would write down the file that you were working on, and the site that it was from, and the date that it was taken on. And you would circle whether it was before sunrise as 1, at sunrise as 2, and after sunrise as 3. And then you would note down in the event would be the species that you detected, and we were doing presence or absence. So once you detected one species, you didn't have to write it down again. And then the time that you heard that, what type of detection you heard, whether it was wing beat, song, call, drumming. And then you would do an audio. You note how far away it is to the recorder. So a 1 would be really close and a 5 would be really far. And then what was really important, and the most important part of this, was that you marked down how noisy it was. So wind, rain, stream noise, any other noise that you heard, whether it was roads. We had lots of planes flying over when in the spring when they're dropping, pesticides and herbicides. So if any of those were too loud, you had to throw out the audio recording so that it wouldn't be biased, and you would, if because it was too loud, you wouldn't hear all of the birds. So we would just have to throw those ones out. And so this is an example of a Raven Pro sonogram from one of my recordings. So in total, I interpreted 270 recordings. And this data interpretation for each recording took anywhere from 5 to 25 minutes, with an average of about 10 minutes per recording. So in total, I spent about 45 hours doing the interpretations. So it was a lot of work. I spent basically all of my winter quarter senior year, when I wasn't doing homework, I was doing this, but it was really fun. So as you can see, there's the really vertical ones are, once you do this enough, you kind of get an idea of what a bird species call looks like. So the really long vertical ones are marsh wrens. So you can see you've got marsh wrens here, and then there's a marsh wren that gets really, really close to the recorder, so it's really loud. There's an elevated kind of upside down U one that's a western wood pewee calling. And then all of this noise at the bottom is just background noise. So you kind of get an idea of what it is like. So on the next couple slides, I have examples of audio recordings that I'm going to play for you guys with the sonogram. So if you want, you can go into the chat and try and guess what birds you hear. And to best do this, I have my volume turned up all the way for me, but it would be best for you to hear the audio recording if you turn up your volume all the way. And if you have headphones in, you'll probably hear it better. But the next one I will play for you is going to be a riparian audio recording. yeah, that is an example of a riparian clip. I don't know if any of you guys have any guesses. But as you can see, the riparian ones are very birdy. I often had to go back and rewind and re-listen. But that's one of the benefits of having the audio recordings, is that you can replay to sort of hear and listen to what you don't understand, or, listen to a call and then replay it on your phone to try and see if you can figure it out. But yeah, the riparian ones are extremely birdy. And then the next one is from a marsh habitat. And then again, that's the example of the marsh. So you can see that one was a little less birdy. You could probably hear some of the farther away birds a little easier. And then there was lots of recordings where you'd have a bird really close, like that marsh wren, and then they would drop out. And then in the rest of that 5-minute recording, you'd be able to hear the farther away birds a little bit better. But yeah, just for example, I'm sure you guys heard these, but there's marsh wren, ringneck pheasant was in there, song sparrow. So yeah, those are just some of the examples of the birds in there. And then the next one I have for you is a bit of a challenge round. The bird that is a challenge is a little bit far away, so it might be hard to hear, but just listen for like a far away trill. And I want to see if you guys can guess what that bird is. Okay, here we go. So that was the trill noise. I'll play it again, just in case you didn't hear it. And then there it was again. So I can't see the chat function, so I don't know if anyone has put in any guesses.
Zane, why don't you read off to her the answers that we have so far on each round?
All right, sure. Well, the only guess for the trill so far is a grasshopper sparrow. If anyone else wants to add. My guess was orange-crowned warbler, but I'm not sure if I still stick with that. I'm waiting for other people if they want to chime in.
No other guesses?
No other guesses.
Okay, so Zane was actually pretty close. It was a northern parula that was in that recording. So it's a warbler, but an East Coast one. And we were actually at Birdhaven. We had deployed the audio recordings, and we were out doing other field work when I was in a cart with Andy, and we were driving by, and the cart was really loud, and we were driving over a wooden bridge, and he goes, stop the cart. And through all of the noise, he heard that trill, and he goes, I think it's a northern parula. And then we paused the cart and then listened, and then sure enough, we heard it, and then he saw it later on the property. And then when we were going through the recordings, I saw this, and I didn't know what it was. So I asked him, and he was like, "Oh my gosh, you got the northern parula on the audio recording." So it was just, it's cool that you can get these birds on audio recorders. And that was fun to see that it had actually gotten it.
I see that both Steve Hampton and Andy mentioned in the first two habitats cedar waxwings.
Yes, yeah, definitely. So then moving on to the data entering. So after all of the recordings were interpreted, I had a lot of data. So I took all of those sheets and I entered them into a spreadsheet for the occupancy to feed into the occupancy model. So this is just an example of that data. And then that was then analyzed. So I calculated gamma diversity in MATLAB by grouping the sites by habitat type and then counting total species richness by habitat type. And then the two equations you see on this slide are what Brett Furness used to interpret the data. So the top one was used for the occupancy model, and again, he is a wildlife ecologist for CDFW, and he's a wonderful statistician and was super helpful. I wouldn't have been able to do without him, but he analyzed all the data in R. And the upper one is for the estimated occupancies, and then the lower one is for detected probabilities. And he did all these by site, survey, and species level covariates. And then these were the results we got. So I detected 46 avian species, including 29 passerines. And so the gamma diversity, or the total species richness, did not differ much between marsh and riparian, but they were both higher than the rice. And so possibly one of the reasons that the marsh and riparian were so close in species richness is that the marsh habitats were surrounded by that cottonwood and willows. So you could hear riparian species in the marsh recordings. I was playing the marsh one earlier, and you could hear a robin in the background. So that's an example of kind of that overlap. And then the results for habitat occupancy. So there were 16 species detected at greater than 10 sites. So we restricted the reporting of the species level results to groups that had been detected than more than 10 sites, because only these species met the requirements to have the statistical power necessary for this occupancy model. So we then use the occupancy model to then see how they differed, their occupancy differed by habitat type. So some patterns to note are that the marsh wren had a higher occupancy in marsh habitat compared to rice or riparian. The redwing was redwing blackbird. So the marsh wren is this one right here. The redwing blackbird right here is more likely to be detected in marsh and rice compared to the riparian habitat, whereas California towhee, which is this one, and the western kingbird, brown-headed cowbird are equally likely to be found in all three habitat types. So these are just kind of very basic community level assemblages that we were starting to tease out with the data. And then the results for species richness by habitat type. I found no statistically significant difference between between species richness using alpha diversity between the marsh, rice fields, and the riparian habitat. But we think, I'll get on to why we think that is. But what's funny about this type of work is that you can do all the work for the interpretations. You spend 45 hours doing the interpretations and you deploy all the data, and then you just, in R, you just press a button and then it creates these graphs in, under 2 minutes. It's cool to see how all that data gets condensed down really fast. But as far as the project summary goes, the method did work, which is great. However, there were some limitations because of sample size. So for statistical relevance, like I mentioned earlier, a species had to be detected in at least 10 sites in order to have the statistical power necessary to be included in the occupancy model, and then therefore the habitat analysis. So since there were only 10 sites per habitat type in our study, a species would either need to be more of a common habitat generalist and occupy the various habitat types, or be a common habitat specialist and be detected at all 10 sites for its specific habitat. So, for example, we were able to include marsh wren in one of those 16 birds because it was detected at all 10 of the marsh sites. And then we were also able to include red-winged blackbirds because they were common in both the rice and the marsh. Whereas, any birds that were more rare or harder to detect, or did not have the statistical power to be able to be calculated in the occupancy model. So in further studies using the audio recording units, it is recommended to increase the number of sites per habitat type so that the statistical power can be increased for the less common species, and more resolution and community community diversity can be determined. And also, the more data you feed the occupancy model, the better it gets. So that's also something that's good to know. Another limitation is that this is a very data hungry project. So or at least the model is very data hungry. So if you are doing an occupancy model, you are going to have to do a lot of interpretations, which do take a lot of time, and that's just something to note. And then finally, another limitation is interpreter skill. So when I first started this project, I was new into birding. I didn't really start birding or know anything really about birds until I got to college. And I didn't start birding relatively seriously until later in college. So my level of audio skills were not at an expert level. So I did miss out on some of the more common birds. Like, I didn't really know housefinch call that well at the time, or goldfinch. So those birds I did miss in the interpreting. But if you were to have a more skilled person look at that to check someone who wasn't as skilled, you could very easily remedy that problem. So then for the future improvement for this method that Brett Furness suggested would be to deploy the audio recording units at least once a month during the breeding season. So in May, June, and July instead of just in May and July. And by making this adjustment, you can calculate the overall peak singing date. And that's really important because that is an indicative of peak breeding activity. So if you want to track long-term monitoring of peak breeding activity, you could do that, and you could track changes in breeding phenology. And then a change in breeding phenology would be evidence of climate change impacts on avian communities. So you could see whether they're breeding earlier in the season or later in the season. And that could give managers another tool to make any informed decisions about the management of their properties. And then also, again, just add more sites per habitat type. And then another future thing that's cool about this is that there are new algorithms that are starting to come out that are being worked on that could make the interpretations, you could do it automatically with a computer instead of having to manually do them, which would make the process a lot faster. And then with all those improvements taken in mind, you could use this method and assess avian occupancy and habitats all across Yolo County. So again, I just want to thank Yolo Audubon for having me and for listening to me. This photo is of an osprey at Birdhaven being chased off by a western kingbird. And this osprey, there's a pair that breed up there, and they have a nest up there, and they usually raise about 2 chicks a year. So they're just one of the really cool birds up on the property. But again, I just wanted to thank you for your time and for having me, and thank you for listening.
Thank you, Danielle. Excuse me. That was pretty interesting. I had this idea of, as I mentioned to you earlier in the week, NASA designed recorders that would stand up
Yeah.
with earthquakes and rain and stuff. And but this is pretty simple that regular people can do this in their backyard,
Yeah.
especially if they're working type. So that's pretty darn cool. I think we have a few questions. Zane, would you do the honors, Zane, and reading off some of the questions, please?
Yeah, for sure. So first up, we have, can you describe the sound quality through the plastic of the container that had the recorder in it?
The quality was not really affected that much by the container at all. It's what the Great Valley Project also used for theirs. They also use the plastic containers. if anything, it helped buff, like it would affect the noise if like raindrops were landing on it, it would be really loud. So you'd hear raindrops dropping and you'd hear really loud marks, but you would just throw out that audio recording anyway. So in an audio recording where there isn't rain or wind, which is ones you'd throw out anyway, it doesn't really affect it that much at all. I was able to hear, these audio recordings work really, really well. So I was able to hear birds like really far away, maybe even out of the 300-meter range. So yeah, it worked well to contain, to keep the recorder safe, but it didn't block out the noise.
Interesting. The next one says, can you determine abundance from this method, or is it just for presence or absence?
You could, like let me go back to that slide. For the data interpretations, there was an option to put the minimum number, which you could use if you wanted to do abundance. However, that requires being able to have a better ear at detecting like exactly how far away you think it is from the recorder, which is when that detection of, or the detection distance of 1 to 5 becomes really important. So I think for the Great Valley one, there have also been studies on this done in like Sierra Nevada, for example, and stuff like that, where I think they did do abundance studies where they would include the birds found in like the 1 to 3 range, which is like average to very close, and then they would eliminate the very far ones. They were, then you have to keep track of listening. Like I heard this, just like you would do in a point count or a transect, where you hear one bird over here, and then you listen to hear if you hear it in a different part of the audio sphere that you have in your head. It is possible, but it's just not something that I did because I did not have the skill level or the appropriate methodology set up at the time for that.
All right. Did you conduct a test of different recorders to determine fit for the project, such as battery life, recording quality, or recording through plastic, or anything of that sort?
So again, these were the type of audio recorders that the Great Valley project used. But as far as battery life goes, I didn't have to recharge any of them during the project itself. They still have great battery life. Yeah, we didn't do extensive testing to see what it would be like with the recorders, if the different recorders would be affected by the plastic or anything like that. But yeah, they worked great and they record really, really well. You could hear a lot of birds from very, very far away. So highly recommend them.
Awesome. Someone wants to know if there are wren tits at Birdhaven.
I think there are wren tits at Birdhaven, yeah.
Okay, cool. And can the data be used in building population models per habitat type?
I'm not sure. I'm sure this is probably a better question for Brett Furness. But I'm sure that you could do something with the audio recorders to get, because you can use them in the point count like manner. So I'm sure you could do some sort of, if you structured how you were collecting the data on your data sheets and you had a clear protocol, I'm sure you could do something to get you the type of data you needed.
Danielle, can I chime in real quick on that question?
Yeah.
So this is Andy Inglis talking. The methodology right now is mostly used for presence absence. But there's a lot of research going on right now looking at how we can use these data to build population models or even to predict abundance. And so, but it just hasn't quite been refined to that level yet. You still don't have the ability to just determine an area that the bird is singing in. So you can't really get any sort of relationship of numbers to an area. So that's the limitation to the method right now. So it's fantastic for looking at presence absence, but it's still developing as a method for other types of avian population type predictions.
All right. And the last question, at least that's been posted so far, is, does the museum plan to continue the project with the stated improvements from one of your final slides?
So right now, I think the next step is to kind of re-go over my data and to work on potentially doing some sort of write-up for it. And then we would need to, it's up to Andy if we want to continue doing the project for it. I think it would be fun to continue, especially now that we can do that peak breeding, now that we know that that's possible to do that sort of peak breeding tracking. I think it would be really cool to continue. But ultimately that depends on funding and how many volunteers and students we have involved. But yeah, I think it would be really cool to continue.
All right.
So can I just chime in on that too, just to kind of expand? We are planning to increase the sample size up at Birdhaven. So I think this coming breeding season, we were going to do it last year, but with COVID restrictions, we couldn't get the manpower to work up there. It was we were on a skeleton crew the whole field season. So our plans are to try to get up there this spring to increase the number of samples to allow us to refine the results that Danielle has already started to sort of tease out of those data. So that is in the plans, but it does, again, we just don't know how we're going to be affected by COVID restrictions in the spring through the university. I want to make one other statement about Danielle. So when she was doing this project, she, I think the day after she did her last recording, she left for Australia and was in Australia for 5 months doing study abroad, and then had to come back and do 270 interpretations, 5-minute interpretations. It is not easy to do, and it was a pretty heroic effort for her to get that all done. So I just wanted to give her a shout out for her effort on that.
Thank you.
All right. Well, that's it on questions.
Okay.
Ken,
Thank
if you
you.
want to take over.
Thanks, Zane. Once again, I'm really pleased that Danielle was able to speak with us tonight. I was pretty well interested in this and very pleased. And I hope all of you that joined us found it interesting and found it innovative. I really hadn't heard of such type of research methodology before this, and I'm glad that Danielle applied for a grant and spoke with us tonight. So Danielle, thank you very much. Really appreciate it.
Thank you for having me.
And let's see what else okay, what am I doing? Okay. So that pretty much wraps it up. Unless, Ann, you have anything to say. I think what want to let you know that next month in February, we have Kevin Gousset, a longtime Yolo Audubon member and board member, and former trip planner for us. He's going to talk with us about a trip to Africa, the Pearl of Africa in Uganda in February. So I hope you all can join us for that one in addition. And in March, we're going to have a talk on marbled murrelets. No title yet or basic description, but it will be on marbled murrelets research. So anyway, there's nothing else. I don't see anything in the chat. I want to thank you all for joining us tonight, and I wish you have a great rest of the evening. Thank you very much. Danielle, great job.
Thank you.
Great job.
Thanks,
Appreciate it.
Danielle.
Zane, thank you.
Thank you, Ken.
All right, folks. Good night.
Night.